So the next statistical thing that we're going to look at are called cumulative frequency curves, also known as ogives. I don't know where that word comes from, or if it has any other meaning whatsoever. Probably does. So often in statistics, you're grouping data together because it makes it easier to work with. So number of customers in a small cinema. These pre-COVID numbers, or this post-COVID numbers, because you couldn't go to the cinema during COVID. So sometimes only 0 to 10 people went to the movie. Have you ever been to a theater with less than 10 people? It's kind of weird. It's happened to me like once. You get into like, oh, I must have picked a really good movie. Because there's nobody in there. Okay? So according to this, between 10 and 20 people happen 4 times, 40 and 50, 32 times, and so on, and very full only once. The cumulative frequency says, where are you at? Well, after 1, you only have 1. But after the second one, you've already tallied up 5 times. Then 5 plus 9, 14. 14 plus 11, you're at 25 people. 25 frequencies have been counted. Now 57 of the frequencies have been counted, and so far. So the cumulative frequency is you're just adding up where are you at with your frequencies. The cumulative frequency can be nice to look at because you can see in total there was 100 different viewings of this cinema, and you can estimate quickly where's the 50th one? Well, the 50th one happened somewhere in here. Where's the 25th one? If I want to find a 25th percentile, about, you can figure that out approximately from there. So what do we do to make the graph representing this cumulative curve? We always put cumulative frequency on our y-axis, and then we'll put customers, because that's the example that we're looking, on the bottom. The scale that I went by is every 2 on the graph is by 10 on both the x-axis and the y-axis. So I'll just let you set the scale up first, and then I'll describe how you draw the dots. So according to our chart, from 0 to 10 has a cumulative frequency of 1. So what we do is we go to the endpoint of 10, and at the endpoint of 10 customers, we label it right at 1. Then after 10 to 20, can you see on your chart the cumulative frequency was at 5? So then at 20, we would mark 5. On your cumulative frequency chart, after 20 to 30, your cumulative frequency was 14. So that means that at the endpoint 30, you would mark a point at 14. So in each of the different group data, you go to the endpoint of that data, and you mark the cumulative frequency. So at the end of 30 to 40, the cumulative frequency was at 25 or 26? 25. So then you would mark at 40 is where you would mark 25. Once you have labeled each of these dots, You start at 0 and draw a smooth curve through them. And this is called the cumulative frequency graph. Tricky things that you have to remember is that you're labeling the points at the end point of the mini ranges. So when you go from 0 to 10, you label it at 10. The dotted lines that are on here give you estimates for the median, quartile 1, and quartile 3. So technically, if we had data points, does it make sense that the median would be between the 50th and the 50th first data point if there was 100? On a cumulative frequency curve, we're using it as an estimate. It says if you had 100, 50 would be the middle. 75 would be quartile 3. 25 would be quartile 1. And the way that you use a cumulative frequency curve to get your data is you just go, okay, across from 50 and down, I would estimate my median to be about 47. Just where my graph comes straight down. Maybe your curve is a tiny bit different. You would get 48 or 46. It's a little bit dependent on how you draw it. Again, it's an estimate. If you looked at the actual data, okay, if you looked at the actual data, the 50th person is in between the 40th and the 50th range. So all you could say from the data is that the median class is between 40 and 50. People who would use the midpoint of that would say, well, then I would say my median is 45. The cumulative frequency curve gives you a little bit better estimate because you've drawn a smooth curve through each of these. It gives more of a sense, well, where in the 40th to the 50th should it be? In this case, I'm saying it's closer to 50 than it is to 40, based on how this curve fits through the data. Interquartile range, well, I go from 25 over and down. I'm going to say quartile 1 is 40. From 75 over and down, I'm going to estimate quartile 3 at 57. Therefore, my interquartile range is 17. And I have to admit that, yes, once in real life, I did make a cumulative frequency curve to find something out. I had a student who wrote a math contest, and they wanted to know, what percentile am I? How good did I do? I got the data back from the math contest, and it gave me all the data in grouped data like this. So I know I shouldn't have geeked out, but I did. So I made the curve to figure out what percentile that student was in, so I could say, hey, not only are you in this class, but you were like 82nd percentile or something like that, so they could either feel good or bad about their results. Usually I would, they had to have done fairly well. I wouldn't have spent all that time just saying, yeah, you're in the 7th percentile. So we call, if we split things into 100, we call those percentiles. Less commonly do you hear things called deciles, but it is a word. So on example 2, can you fill in the cumulative frequency chart part? And then create your own scale and draw a cumulative frequency curve to the best that you can. There's also a cumulative frequency polygon, which we drew a nice curve through each of the points. If you just joined the points with a straight line, it also is a pretty good estimate, not as good as the curve, and that's called a cumulative frequency polygon when it's straight. We're going to end with this example, just so that it's on the video. I'll have the numbers show up, and I'll have a picture of the graph as a cumulative frequency polygon, so I drew them with a straight line. And we'll go over answers C and D at the beginning of next class. But I'll stop.